For 70,000 years, it slept. A massive volcanic peak in southeastern Iran, dismissed by science, forgotten by time. Mount Taftan, a name that translates to the Burning One, had earned its rest, or so we thought. Then the mountain began to rise, not in violent eruption, not in catastrophic explosion, but in something far more unnerving, a slow, measured awakening, detected only by the unblinking eyes of satellites circling overhead. And Taftan isn't alone. Across the globe, mountains we declared dead are showing signs of life. The question isn't if they'll wake up, it's when. Welcome to the age of the restless Earth. We stand at a moment in geological history where our technology has finally caught up with the planet's secrets, revealing that the ground beneath our feet is far less stable than we ever imagined. Today, we're investigating two volcanic systems that are rewriting everything we thought we knew about extinction. Mount Taftan in Iran, a giant that's been silent since the last ice age, now showing unmistakable signs of resurrection. And Italy's Campi Flegrei, a supervolcano lurking beneath 500,000 people, swelling like a geological time bomb. These aren't just scientific curiosities, they're warnings written in the language of the Earth itself, and we're only just learning how to read them. The discovery came not from boots on the ground, but from space. Synthetic aperture radar satellites, capable of detecting ground deformation down to millimeters, began registering something impossible. Taftan's summit, a massive caldera spanning 4 kilometers, was rising. Not collapsing, not eroding, but actively inflating. Week by week, month by month, the mountain was swelling from below. For geologists, this was like watching a patient declared deceased suddenly draw breath. Taftan rises nearly 4,000 meters from the desert floor, its twin peaks dominating the landscape between Iran and Pakistan. Steam vents along its flanks have hissed for centuries, dismissed as mere remnants of a bygone era, but that steam tells a different story. Below the surface, something is moving, heating, pressurizing. The satellite data revealed ground uplift, concentrated around the central crater, exactly the pattern you'd expect from fresh magma, pushing upward into the volcano's plumbing system. The mountain was recharging. But here's what makes this truly alarming. Taftan sits in one of the most seismically active regions on Earth, where the Arabian Plate grinds relentlessly northward into Eurasia. This isn't a volcano waking up in isolation. It's waking up in a war zone of tectonic forces, where earthquakes can act like matches struck near a powder keg. And the powder keg is getting fuller. Now, if you're imagining Taftan erupting in a fountain of lava, a spectacle of fire against the desert sky, hold that thought. Because the real danger is something far more insidious. Phreatic eruptions. Steam-driven explosions. These are the assassins of the volcanic world. They strike without the warning signs we've come to rely on. No dramatic magma ascent, no weeks of escalating earthquakes. Just water meeting heat in the wrong place at the wrong time. And suddenly, rock that's been solid for millennia is transformed into a projectile weapon. Taftan's summit is riddled with hydrothermal systems, groundwater circulating through fractured rock, heated by the awakening magma below. When that water flashes to steam in a confined space, the pressure builds exponentially. And when it releases catastrophically. We've seen this story before. Mount Ontake in Japan, 2014, hikers enjoying a perfect autumn day on the summit when the mountain exploded with zero warning. 63 people died, buried in superheated ash and rock. No magma ever reached the surface, just steam, finding its escape route through the paths of least resistance, paths that happened to be filled with people. Taftan's awakening follows this same terrifying script. The ground is heating. The hydrothermal system is pressurizing. But we have no reliable way to predict when or if that pressure will find its release. The mountain could simmer for decades, or it could explode tomorrow. And here's the nightmare scenario. If a phreatic eruption does occur, it could destabilize the magma system below, triggering exactly the kind of magmatic eruption we've been worried about all along. One event cascading into another, each feeding the next, until the mountain that slept for 70,000 years reminds us why ancient peoples called it the Burning One. Now shift your attention westward to the sun-drenched coast of Italy, to the Bay of Naples, where Vesuvius looms over the city in iconic menace. But Vesuvius, for all its historical infamy, is the distraction. The real monster sleeps just to the west. Campi Flegrei, the Phlegreian Fields, a supervolcano hiding in plain sight. This isn't a mountain. It's a caldera, a collapsed magma chamber spanning over 100 square kilometers, 13 kilometers across, of restless, swelling earth, dotted with 24 separate craters. And unlike Taftan's empty desert surroundings, 500,000 people live directly on top of it. The caldera was born in violence. 39,000 years ago, Campi Flegrei erupted with such force that it ejected over 300 cubic kilometers of material into the atmosphere. Ash from that eruption has been found across Eastern Europe. It was quite possibly one of the events that pushed Neanderthals toward extinction, choking the sky and plunging the planet into volcanic winter. The caldera's one last major eruption in 1538 lasted 8 days and built an entirely new mountain, Monte Nuovo, still standing today as a monument to the power sleeping below. But what makes Campi Flegrei truly terrifying isn't its past, it's its present. The ground is rising, not in millimeters, but in meters. Since the 1950s, the town of Pozzuoli has risen and fallen like a geological yo-yo, pushed upward by magma and hydrothermal fluids accumulating below. In the 1980s, the uplift was so severe that thousands were evacuated. The crisis passed. The people returned. But the mountain never stopped moving. Recent data shows acceleration. The caldera is entering what scientists call unrest. Increased seismic activity, ground deformation, changes in gas emissions. The magma chamber, sitting just 3 kilometers below the surface, is recharging. How much? How fast? These are questions without clear answers. And here's where it gets even more complex. Campi Flegrei doesn't behave like a normal volcano. Its eruptions can be wildly variable, from small phreatic blasts to civilization-ending super eruptions. The same volcanic system, radically different outcomes. Predicting which type of eruption might come next is like trying to predict whether a pot of boiling water will overflow gently or explode across the kitchen. We simply don't know. So what connects Taftan and Campi Flegrei? Why are we seeing volcanoes wake up across the globe? Mountains we'd written off as extinct suddenly showing signs of life. The uncomfortable truth is, we never understood volcanic extinction in the first place. For decades, we classified volcanoes into neat categories: active, dormant, extinct. But these are human constructs imposed on a planet that operates on geological time. To the Earth, 10,000 years is a blink. 70,000 years barely registers. What we call extinct, the planet calls resting. And now, our technology has advanced to the point where we can detect that rest being interrupted. Satellites, seismic networks, gas sensors. We've built a nervous system for the planet, and it's telling us something we didn't want to hear. The Earth is more active than we thought. Climate change may even be playing a role. As glaciers retreat, They remove enormous weight from volcanic systems that have been compressed for millennia, remove the pressure, and magma finds new pathways to the surface in Iceland, in Alaska, in the Andes. Deglaciation and volcanic upticks are showing disturbing correlations. We're not just monitoring volcanoes anymore. We're watching the planet respond to changes operating on multiple scales simultaneously: tectonic, climatic, magmatic. And the responses are accelerating. Taftan's awakening, Campi Flegrei's swelling. These aren't isolated incidents. They're symptoms of a planet in transition, responding to forces we're only beginning to comprehend. So here's where we stand. Mount Taftan continues to rise, millimeter by millimeter, monitored by satellites but largely ignored by the world. Its steam vents hiss louder. Its ground swells higher. The mountain that was dismissed as dead is proving it still has stories to tell. We just might not like how those stories end. Campi Flegrei's 500,000 residents go about their lives on top of one of the most dangerous volcanic systems on Earth. Scientists watch the data, models run continuously, evacuation plans sit in drawers, waiting for a signal we're not sure we'll recognize in time. And around the world, other giants are stirring. Mountains we thought we knew, revealing depths we never imagined. The age of predictable geology is over. We live now in an era of surveillance, of constant monitoring, where the ground itself has become a subject of intense scrutiny. We've learned that extinction, in the volcanic sense, is more of a comma than a period. A pause in the conversation, not its end. The question that keeps volcanologists awake at night isn't whether these systems will erupt again. It's whether we'll recognize the signs in time, whether our technology and understanding can keep pace with forces that have been building pressure for tens of thousands of years. Taftan is rising, Campi Flegrei is swelling. And beneath our feet, all across the planet, the Earth is remembering how to speak in fire and ash. We'd better learn to listen.